Raise your right hand in front of a mirror. The other you raises the wrong one. So why doesn't your head end up at the bottom? If mirrors really swap left and right, why are they so selective? There's one direction, the mirror asterisk changes, and your brain quietly hides it. Stand in front of a mirror and do something simple. Raise your right hand. The person in the mirror raises what looks like their left hand. So the story everyone learns without even being taught is mirrors flip left and right. And then someone asks the viral question, the one that makes people argue in the comments like it's a moral issue. Why does the mirror swap left and right but it doesn't swap up and down? Because if the mirror is some kind of swapping machine, why is it so picky? Why isn't your head suddenly at the bottom? Why don't your shoes appear up by the ceiling? You know what most answers sound like? Little poems about perspective. Or because your eyes are on the left and right. Or some vague thing about how mirrors reverse the image. Reverse what exactly? Let's slow down. Because the moment you slow down, the whole confusion shows itself. A mirror is just a flat sheet. It doesn't have a preference for left versus right. It's not a political statement, it's geometry. So here's the first move. Stop talking about left and right like they're written on the universe. Left and right are labels you carry around with your body. The mirror isn't flipping labels. It's doing something physical to directions in space. You can feel it if you do the dumbest possible experiment. Put one finger on the mirror, not near it, not pretend touching. Actually touch the glass. Now look at the image finger. Where is it? It's not on the left. It's not on the right. It's behind the mirror. That's where it appears to be. Your real finger is in front of the mirror. In the room with you. The image finger is the same distance on the other side. In the world that isn't there. So what did the mirror do? It took the direction in front of the mirror and turned it into behind the mirror. Front became back. That's the only direction that got reversed. Not left right, not up down. Front back. Toward the mirror versus away from the mirror. And already you can see the trap. We rarely use front and back as abstract directions in space. We use them as body directions. The front of me, the back of me. But the mirror's front and back are not about you. They're about the mirror plane. There's toward the mirror and away from the mirror. That's it. So why, when you look at your reflection, does it feel like left and right are swapped? That feeling is real. It's not stupidity. It's a mismatch between two different operations that your brain quietly blends together. One operation is what the mirror does. It flips the world through a plane, a geometric reflection. The other operation is what you do mentally. You try to imagine the person in the mirror as another person facing you, and to make them face you, you secretly rotate them in your head. You turn them around so you can compare them to yourself. That rotation is where left and right get scrambled. Not in the mirror, in you. Let's be very concrete. Imagine there's a little arrow sticking out of your chest, straight forward, like a toy arrow glued to your shirt pointing where you're facing. When you stand in front of the mirror, your real chest arrow points toward the mirror. In the reflection, the arrow points away from the mirror, back into the mirror world. So forward became backward. That part is clean. Now do the same with an arrow pointing upward from your head. Up is up. Gravity doesn't care about your drama. In the reflection, the up arrow still points up. No surprise. Now put an arrow pointing to your right. The direction your right arm sticks out if you extend it sideways. In the reflection, that arrow still points to the same side of the room. It's still toward the wall on your right. The mirror did not swap the rooms left and right. The room stays the room. So where does the swap appear? It appears when you stop talking about the room and start talking about the person. Because you don't compare your right hand to the room's right. You compare it to their right. And their right depends on which way they're facing. That's the whole trick. Right and left are not absolute in space. They're tied to an orientation, to a facing direction. So when you look at the reflection and you say, that person's left hand is raised, you've already committed to a viewpoint. You're thinking of that image as a person facing you, like another human standing there. But in pure geometry, the reflection is not a person who turned around. It's you, reflected through a plane. It's as if the space behind the mirror were a continuation of space in front, and everything gets copied through the glass with only the perpendicular direction flipped. That's why touching the mirror is the cleanest experiment. The touch direction toward the mirror is the one thing you can't argue about. It's physically singled out by the mirror plane itself. So here's a better way to state the problem, a sharper one. When you look in a mirror, you feel a left-right reversal, yet the mirror's geometric action is a front-back reversal relative to the mirror. So why does your brain report left-right? And if you want to go one layer deeper, and we will, what is it about left-right that makes humans so fragile about it? Why is there even such a thing as handedness in space? Why is left-right a more delicate idea than up-down? Because up-down has gravity to anchor it. You can close your eyes and still know which way is up. Your inner ear screams it at you. Front-back has your body and your motion. You face things. You walk forward. You have a built-in arrow. Left-right is different. It's defined only after you choose an orientation. It's the direction perpendicular to both up-down and front-back. It's a kind of leftover direction. And there's a deep reason that matters in physics. Flipping left-right is not the same as rotating things. A rotation keeps the handedness of space. A mirror flip changes it. That's where the word parity comes in later. Not yet, not the heavy version. Just the everyday version. What counts as a true mirror flip versus what counts as simply turning around. But before we even touch that, we have to nail the everyday confusion with a simple question. What exactly are you comparing when you say the mirror swapped my left hand? Are you comparing your left hand to the image's left hand? Or are you comparing your left hand to the image's hand that appears on your left side? Those are not the same comparison. They only feel the same because your brain is fast and lazy and it wants social situations. There's another person. Try this. Write the letter R on a piece of paper. Hold it facing the mirror. The mirror shows the R backward, like the kind of writing you see on the front of an ambulance, so you can read it in your rearview mirror. Now ask, did the mirror flip left-right on the paper, or did it flip front-back? If you physically turn the paper around, you can make it look like the mirror image. But you had to rotate it. You had to do something. And that something is the clue. Because the mirror didn't rotate anything. It just reflected. The paper rotation is you trying to match two objects that are oriented differently in space. That's the game your mind is playing with your own body in front of the mirror, too. You want the mirror person to be a person like you, so you mentally rotate them to face your way. And that mental rotation is what turns a front-back flip into an apparent left-right swap. That's the problem in one sentence. The mirror flips one axis. Your interpretation adds a rotation, and the combination looks like a left-right flip. That's part one, just setting the battlefield. Next, we're going to build a clean coordinate system you can actually feel without equations, and we'll catch the exact moment where left-right sneaks in. And once you see it, you can't unsee it. So let's build a set of directions you can't wiggle out of, not left and right as feelings, real directions in the room. Pick 3 arrows, 1 up, down, that one is easy, gravity nails it to the wall. Up is where the ceiling is. 2 toward away from the mirror, put your palm on the glass again. The direction your finger points when it presses the mirror is toward. Pull back away. This axis is special because the mirror itself singles it out. It's the direction perpendicular to the mirror surface. 3. The third direction is whatever is left along the mirror sideways across it. Call it along the mirror. Now here's the key fact about a plane mirror. No mysticism, just geometry. A mirror keeps the components of your position that lie along the mirror, and it reverses the component perpendicular to the mirror. That's it. If you're 30 centimeters in front of the mirror, your image is 30 centimeters behind it. If you move 10 centimeters to the left along the mirror, your image moves 10 centimeters to the left along the mirror. If you move 5 centimeters up, your image moves 5 centimeters up. Only the toward away coordinate changes sign. So if we want to say it in normal human language, a mirror flips front back relative to the mirror. And now you can answer the why not up down question in one move. It's not that a mirror refuses to flip up-down, it's that this particular mirror is vertical, so up-down is not perpendicular to it. If you put a mirror flat on the floor and look straight down at it, now what happens? Up-down becomes the perpendicular direction. Your reflection is below the floor. It's like the world continues under your feet, and suddenly the up-down thing flips. Your raised hand points up in the real world, and the image hand appears to point down into the floor world. The mirror didn't grow a new personality. You just changed which axis is perpendicular. So the mirror is consistent. The confusion is us naming directions with our bodies. Now we've said front back, but we have to be careful. Front and back of what? Of the mirror plane. Because the moment you bring in your body, front means the direction your chest faces. That's a different arrow. And this is where the left-right drama is born. Let's do a slow-motion mental experiment. No equations, just a careful movie in your head. Imagine you have a big letter F written on your chest, big enough to see from far away, and imagine a tiny arrow stuck to it pointing out of your chest. Call that arrow your forward. You stand facing the mirror. Your forward arrow points toward the mirror. Your reflection's forward arrow points away from the mirror into the mirror world. So far, nothing about left-right. Clean. Now ask, when you look at your reflection, what do you instinctively do? You treat it like another person standing there facing you. But the reflection is not you turned around. It's you with front back inverted through the mirror plane. If you want the reflection to be another person facing you, you do a mental rotation. You spin the reflected person around in your imagination so they face the same direction you face, and the moment you rotate a person, left and right can trade places, depending on the axis of rotation. Here's the simplest way to see it. Take a real person, not a reflection, standing in front of you, facing you. Which hand is on your left side of the room? Their right hand. Because when someone faces you, your left side corresponds to their right side. That's not mirror magic. That's just what facing means. Now notice what you just did. You didn't compare your right hand to their right hand. You compared your right hand to the hand that appears on your right side. Those are totally different comparisons. So when you say the mirror swapped left and right, you are secretly mixing two coordinate systems, minus the room's coordinate system, left side of the room, right side of the room, the body's coordinate system, my left, my right. The mirror acts in the room's geometry. It flips the toward-away axis. Your brain reports the result in body language. It tries to assign my left and my right to the reflected figure. And to do that assignment, it does a rotation. Let's catch that rotation explicitly. Imagine the mirror is a doorway into a second room behind it. In that second room, there's a copy of you, same posture, same height, same everything, except their forward arrow points away from the mirror because they are the reflected version. Now you standing in front want to compare yourself to that copy as if they were you. Same orientation, same facing direction. How do you make them face the same way as you? You rotate them 180 degrees around a vertical axis, literally spin them around, so their chest arrow points the same way as yours. After that rotation, now you can talk about their left hand in the same sense as my left hand, because you're both facing the same way. But here's the catch. This is the whole catch. A mirror reflection is not a rotation. A rotation preserves handedness. A mirror reflection reverses handedness. So when you try to fix a mirror image by rotating it into alignment, something else has to give. And what gives is left-right. You can feel this with your hands. Do it. Hold up your right hand and make an L shape with your thumb and index finger. You know, the classic L for left, except you're doing it with your right hand, so it's not an L, it's the other one. Now look at the mirror. The mirror hand looks like the opposite-handed version. If you try to match it with your real hands, you'll find you need your left hand to match the mirror's right hand shape. That's handedness, chirality, that cannot be rotated into property. A right hand cannot be rotated to become a left hand. You can spin it any way you want in 3D space. It stays a right hand. But a mirror can turn a right hand shape into a left hand shape because a mirror is doing a reflection, not a rotation. So now we can say something sharper than front back. A mirror flip changes the handedness of a coordinate system. And that's why left-right starts to matter, because left-right is the thing that tells you whether your coordinate system is right-handed or left-handed. Okay? That sounds like math class. But it's not. You can do it with your own body. Make a 3-arrow system with your right hand. Thumb equal sign one direction, minus finger equal sign second direction, middle finger equal sign third direction, perpendicular to the first two. This is the classic right-hand triad. You can choose which is which, but once you pick two, the third is forced. Now do the same with your left hand. You get a mirror version. It looks almost the same, but it's not rotatable into the right-hand version without going through a mirror. That almost the same but not fixable is exactly what the mirror does to space. So the mirror doesn't swap left-right like it's moving labels around. It reverses orientation. It produces the left-handed version of your right-handed world. Now why doesn't that feel like front-back when you look at your face? Because your face is nearly symmetric front to back. No, your face is very not symmetric front to back. Your nose is a dead giveaway, so why aren't you constantly screaming, "My nose points the wrong way"? Because the mirror doesn't show your nose pointing away from you. You are still looking at your nose from the front. What changed is depth. The nose is the thing that sticks out toward the mirror, and in the mirror world it sticks out away from the mirror. That is a depth reversal. Your visual system is surprisingly tolerant of depth reversal when it's presented as a flat image. It doesn't shout. It just accepts, okay, that's a reflection. But your brain is very sensitive to social body mapping, which side is which on a person. So you walk right into the trap. You treat the reflection as a person facing you, which automatically switches left and right in your interpretation. If you want to see it without your face confusing you, don't use your body at all. Use an asymmetric object that has a clear front. Take a shoe, put the toe toward the mirror, look at the reflection shoe. The toe points away in the mirror world. That's the flip. Or write a word on a transparent sheet and face it toward the mirror. The mirror shows it reversed in the depth sense. Then when you view it as if it were facing you, it reads backward. Again, mirror does depth. Your facing interpretation turns it into left-right confusion. So the honest summary of part 2 is, the mirror flips the perpendicular axis. Your brain insists on comparing me to a person facing me. That comparison includes a rotation, and rotation plus reflection is what produces the apparent left-right swap. Next, we're going to make this so concrete it becomes almost annoying. We'll track one specific point, like a sticker on your cheek, and watch what the mirror does versus what your mental rotation does. Then we'll connect it to the real physics word for this, parity. Not as a scary symmetry, but as the simplest possible question, is the universe the same in a mirror? Let's do the sticker test. It's the simplest way to separate what the mirror does from what your brain adds. Imagine you put a bright red sticker on your right cheek, not the right side of the room, your right cheek, the one you would point to if someone asked which side is your right. Now you stand in front of the mirror. Where is the sticker in the reflection? You'll say it's on the left cheek, and that's the moment the confusion feels airtight. But watch what you're doing. You're not describing where the sticker is in space. You're describing which cheek it belongs to on a person. So do the space version first. In the room, the sticker is still on the same physical side of the room as your right cheek. The mirror doesn't teleport it across. If your right cheek is closer to the door, the reflection sticker appears closer to the door too. Up stays up. Sideways in the room stays sideways. Only depth flips. The sticker is toward the mirror in the real world. It becomes away from the mirror in the mirror world. So where does left cheek come from? It comes from you taking the reflected figure and pretending it's a person facing you. When a person faces you, their right cheek is on your left side. That's not a mirror effect. It's a facing effect. You can prove it without a mirror. Stand in front of a friend. Put a sticker on your right cheek. Tell them to point to the cheek that corresponds to your sticker on their own face. They'll point to their left cheek because they're facing you. So the mirror isn't doing something special to left and right. Your social brain is. And once you see that, the why not up-down question changes shape. It becomes, why do humans think mirrors swap left-right in the first place? Because up is the same for both of you. Gravity gives you both the same anchor. If you face someone, their up is still up. No ambiguity. But left and right are relational. They depend on orientation. They're not painted on the room. Now we can name the deeper idea without scaring it away. A mirror changes the handedness of your coordinate system. Physicists call that a parity transformation. Parity is just the question, what happens if you replace the world with its mirror image? Not the world rotated, not the world viewed from behind, the world reflected, handedness reversed. If you've ever tried to put on someone else's glove, you already know parity is not a joke. A left glove is not a right glove that's been rotated. It's a different object in a deep sense. Same for your hands, your shoes, the spiral on a seashell, the twist in a corkscrew. Those things have chirality. They come in left-handed and right-handed versions, and a mirror swaps them. Now here's the punch that makes this go from cute perception trick to real physics. For a long time, people believed nature itself didn't care about left and right, because most of the fundamental laws look mirror-symmetric. Electromagnetism? Mirror it, fine. Gravity? Mirror it, fine. The equations don't pick a handedness. So it seemed like parity was sacred. If you ran the universe in a mirror, everything would behave the same way. Then the universe pulled a fast one. In the 1950s, physicists found that the weak interaction, the force responsible for certain kinds of radioactive decay, does care about handedness. It violates parity, meaning the mirror universe is not identical to ours in every detail. There are processes where left and right are not interchangeable. That's not philosophy, that's experiment. This is the part where people get tempted to turn it into a mystical story, like the universe has a preferred political side. Forget that. The clean statement is there exist physical processes that distinguish a right-handed coordinate system from a left-handed one. The mirror world is not always allowed to be the same world. So your mirror confusion, this little everyday argument about which way is flipped, is actually brushing against one of the most shocking facts we learned about nature. Left and right are not purely human labels. Under the right conditions, the universe itself keeps track. Now, you don't need the radioactive decay experiment to understand the mirror, but it's a beautiful connection because it tells you something about the structure of explanation. A mirror flip is not a thing turning around. It's a change in orientation that cannot be undone by rotations alone. And that's why the correct mental model of a mirror is not, it swaps left-right, it reverses the direction perpendicular to its surface. Everything else, every feeling of left-right reversal, is a consequence of you trying to compare bodies. So here's the question I want you to keep, because it's the only one that matters. When you say the mirror swapped left and right, what are you carrying into the mirror? Are you carrying labels attached to your body, or are you tracking directions in space? Because a mirror is brutally honest. It only acts on space. You supply the personhood. You supply the facing. You supply the rotation. And once you realize that, you start noticing this pattern everywhere. A lot of mind-blowing puzzles are just you mixing coordinate systems without noticing. We do it with time. We do it with motion. We do it with now. We do it with up when you're in a plane doing a barrel roll. The world didn't get weird. Your reference frame did. So the next time someone says mirrors flip left and right, you can say something better than actually no. You can say a mirror flips front back. The left-right switch is what you get when you imagine the reflection as a person turned around. And if they push back, don't argue. Give them the sticker test, or the glove test, or just the finger on glass test. Touch the mirror. Ask, where is the image finger? It's not to the left. It's not to the right. It's behind. That's the axis the mirror actually cares about. And here's the quiet existential ending, because it's worth it. When you look into a mirror, you're not seeing you. You're seeing a perfectly consistent mathematical operation applied to your entire world. A parity flip across a plane. A sheet of glass is showing you an alternate version of space, one you can't step into, but one you can reason about. And the fact you can get confused by it isn't embarrassing. It's proof that your brain is doing physics all day long just without calling it that. If you want more of these places where everyday intuition crashes into clean geometry and the universe wins, stick around. Because the real fun isn't memorizing facts. It's catching yourself in the act of assuming something and then watching nature refuse to cooperate.